Professor Howe is a developmental psychologist whose research lies at the interface between psychology and education. Her main interests are children's conceptual knowledge, particularly in the domains of science and mathematics, and children's peer relations and communicative competence. For the past 20 years, she combined these two interests of children's conceptual knowledge and peer relations using research and using consultancy. In this context, she focused on interactive learning in peer group, tutor-led and computer-mediated settings. Professor Howe published many articles in international journals like Cambridge Journal of Education, Journal of Experimental Psychology, International Journal of Science and Mathematics, Education, Learning, Culture and Social Interaction, Journal of Developmental Psychology, Learning and Instruction and Social Development. So you see a broad range. She is past, respectively present editor of several international journals and is part of many editorial boards. Professor Howe's research on collaborative learning in science has attracted considerable media attention and has had significant impact on policy and practice. In 2006, she was elected chair of the British Psychological Society's developmental section. In 2008, she was elected member of the Academy of Social Sciences. Professor Howe is married. She has 2 children and enjoys music, art, film, theater, traveling, hiking, tennis, learning languages, playing bridge. But we are very glad now to hear your lecture on dialogue and knowledge transformation towards socio-cultural theory and cognitive growth. So please come.
Very nice and a little daunting to see so many of you here, but I'll do my best in the next hour to talk from the perspective of my own research on the theme of dialogue and knowledge transformation. It's actually been an interest of mine throughout my research career. My PhD dissertation was on mother-child dialogue and the child's acquisition of syntax. So, you know, already at what feels like 100 years ago, I was looking at precisely this topic. However, about 25 years ago, I moved away from a focus on adult-child relations to looking at dialogue in peer group, collaborative contexts. And I also moved very gradually away from a focus on the acquisition of the implicit knowledge of grammar that everybody acquires to the acquisition of understanding of formal school topics. And it's that area of research that I want to talk about today, to talk about the message from my work on collaborative learning in peer group settings for the acquisition of school-related knowledge. Before I begin, I want to say that the research I'm going to be talking about is a truly collaborative exercise. It's been conducted with a large number of other people some of whom I can see in the audience. I can't see too far in the audience, but certainly some of my collaborators are here, and I want to acknowledge their contribution. I won't be able to, in the space of an hour, to put all the names up, but it's not an individual venture that I'm going to be talking about. The talk's in 3 parts. The first part will be relatively brief. I'm going to give a kind of lightning review of my published research on on productive dialogue during collaborative group work. It's going to be a brief summary because I know there's lots of people here who've heard it lots of times before. The slides that I'm going to show will be familiar to people in the audience. And it's a and therefore I just want to use it to set the scene for what I'm going to focus on in the second part of the talk, which relates to age-related changes in the process of collaborative learning. And I'm going to be outlining some new research stimulated by, of course, everything that went before, which examines the nature of the changes, the way in which the processes of collaborative learning may or may not change with age, and draw some theoretical implications. And then in the final part, I want to talk, again, fairly briefly, about what all this amounts to in terms of the underlying processes. What are the processes of knowledge transformation that are going on as a result of collaborative dialogue, and make my my very modest and restricted sort of bid to contribute to a socio-cultural theory. So, part one, the nature of productive dialogue during collaborative group work. I started doing this work more than 25 years ago, getting on to 30 years ago. And there are now around 30 studies that I've been involved with, published between 1990 and 2009, and the one new study, which I'm going to be talking about in greater detail later on. All these studies are concerned with the impact of collaboration amongst small groups of students upon mastery of curriculum relevant topics. In a sense, I've said that already. And most of the studies involve analysis of the group dialogue. They cover a lot of topics. They cover topics in mathematics, in science, in social science, and also general reasoning. And I've listed, I think, most of the topics, but certainly not all of them, that there's at least one study addressing. What I'm going to do today is focus on the science-related studies that are concerned with force and motion. That's because this is the topic of the new study, and everything will be a lot clearer if I restrict all the examples to that. But even in the area of force and motion, you can see that we've looked at quite a wide range of topics. We've looked at horizontal, vertical and incline motion. We've looked at speed and direction. And we've looked at motion through air and also motion through water. And as you'll hear as the talk progresses, we've done quite a lot of studies on floating and sinking. So it's this kind of area that I'm going to use. However, I should emphasize that what I'm going to say in this part of the talk actually relates to pretty well all of these topics. They cover a wide age range, late primary, 8 years is about the youngest group we've worked with, but we've certainly covered all the primary age groups beyond that, secondary, early secondary, and we've done some work with undergraduates. The majority of the studies are researcher-delivered, but in school context, using school-related topics. But a significant number by now, and particularly since I've been working in the Faculty of Education rather than the Department of Psychology, have been teacher delivered in authentic settings with the group work component embedded in normal curriculum teaching. Whatever the context and whatever the age range, they have a fairly standard 3-stage design, all with some individual pre-test to look at the students' initial understanding, sometimes one-to-one interviews, but as we've got more confident with the areas that we're working in, we've been able to develop written tests, which of course can be administered a lot more quickly than individual interviews. So we've used both methods. Then, of course, the crucial stage, a collaborative group task. Always in the science studies, they have the format that the groups work together to formulate some joint prediction. They then test it out using physically present apparatus, and then they're asked to interpret what they observe. We've used a variety of group sizes. I've said there pairs, triads, or foursomes, and they would, these would be the common group sizes in our research. We've actually also used bigger groups up to sort of 6 or 7 students in a few studies, but quite a wide range of group sizes. Sometimes we've used a task that's workbook presented, as one of the students has the book and directs the group as they work through it. Sometimes we've used a computer to present the instructions. And then the final stage is an individual post-test, exactly the same format as the pre-test, often with slightly different problems. Always our post-tests are delayed. We're interested in, sort of long-term learning, usually about a month after the group task. Sometimes we also have an immediate post-test, and in one study we had a delayed post-test and a very delayed post-test, one at 4 weeks after the group task and one at 11 weeks. But always there's one post-test about a month after. Now, whenever I talk about this research, it's a souvenir to myself, really. I like to show this picture, because this is from the very first study that we did on collaborative group work. I'm sure these children, who were about 11 years of age at the time we recorded them, are now in their mid-30s. But there they are, working on floating and sinking. The little boy on the left has the workbook directing the group. There's a fish tank on the table, and the kids have written down, made predictions about whether a series of objects will float and sink. They're just about to test one out and interpret what happens. And those 2 green boxes, they put the objects in according to whether they float or sink. The point is, well, there are 2 points really. Very simple apparatus. Exactly the kind of things that can be used and are used in classrooms. There's nothing complicated about the way we set these things up. And the teacher's not there. And the researcher's not there, except in the sense of wielding the camera. We're interested in the dialogue and the group practices that occur when the children are working as a group. So, I've emphasised the sort of wide range of topics and the range of procedures within a general format. There's one key finding that we get in just about every single study. In fact, we've never had a study that contradicts this. Difference of opinion is helpful. Pre to post-test progress is greatest when the group members hold different ideas than when they hold similar ideas. And pre to post-test progress is strongly associated with the extent to which group members discuss differences, the extent to which they make contrasting proposals about group solutions, the extent to which they doubt each other's proposals, the extent to which they justify their opinions. It's this form of dialogue that appears over and over again in our research as crucial. And nothing I'm going to say today contradicts this. I'm going to elaborate on it a little bit, but it is a very strong finding in our research. And it is difference of opinion that's important. It's not, for example, differing ability, whereby a more advanced student, who obviously will have a different opinion from a less advanced student, tutors the less advanced student. Because in precisely those kind of groups, asymmetric groups, where you've got one student with greater understanding than another, the more advanced students also progress. The more advanced students and the less advanced students progress. With some of the topic areas, floating and sinking is a particularly good example of this. You can have students differing but actually being at the same level of understanding. If one student thinks a crucial thing for sinking and floating is whether an object's shiny or not, and another thinks that a crucial thing is whether the immersed object has germs or cornflakes or bones or something inside themselves, then you know, these are the things I've actually heard children say, then you wouldn't say that either of them have got very good levels of understanding. And if you put children with these, a mixture of these very primitive ideas together and have, in effect, a symmetric group, again, you find progress. And indeed, what we find in our studies is that differences at the same general level of understanding as effective as asymmetry. So it is an effect of difference of opinion. That's absolutely crucial, and it really is pretty robust across these studies. So I think it's important, before we move to the new stuff, for you to just have a look at the kind of dialogue that, in effect, I've been saying is productive. I should perhaps say that in the half a dozen or so transcripts I'm going to show you in the course of the talk, I'm using pseudonyms for the children's names. The pseudonyms are gently suggestive of their gender and their ethnicity, but they are in fact pseudonyms. So this dialogue comes from a fairly early study published in 1992, where the kids are working on motion down an inclined plane. They're asked to predict how far a car will roll along the floor, well, roll down the plane and then along the floor, when things like the surface friction of the slope varies, the rough surface, the angle of the slope varies, the higher track, and another variable that's crucial to this one is the starting gate on the slope. The car could start from a gate high up, middle, or low down on the slope. So, you know, these are the things that vary in this situation. And if you just skim through, I mean, they don't understand the science, but the point is it's a productive discussion. There's a lot of difference of opinion. It'll go, I think it will go to the further one. I think it's the same square. There are 3 squares on the floor because it's quite high and it's in the middle one. That means the middle gate on the slope. But the rough surface will stop it getting a good... I don't think the higher track and rough surface will matter. Okay, friction's not important. So it'll go to the same square. They've already seen a car roll down the slope, and so on. So this kind of discussion that is predicting gain in so many of our studies. We need to keep that in mind as I move on. So when I started this research, I fully expected the mechanism of learning to be the one that would be predicted from Vygotsky's very famous quotation. Every function appears first between people and then inside the child. What I expected to happen was that the groups would co-construct some better level of understanding, and the individual children would take that better level of understanding away, and that would be their post-test performance. How naive, because I found absolutely no support for this idea in my 8 to 12-year-old sample. And here's a list of the things that I would say that at least one of these, and sometimes all of them, appeared in every study that we did with this age group. Firstly, the co-constructed solutions were often worse than the pre-test performance of the individual group members. Second, there was usually no relation whatsoever between the quality of the co-constructions and subsequent growth, pre to post-test change. There were some stroppy groups that agreed to differ, at best. They couldn't come to any agreed solution, despite the fact that task instructions were pressing the groups to come to some agreement. These groups that couldn't resolve their differences were often as effective in terms of pre to post-test change as the groups that achieved consensus. And I think most importantly, understanding was found in the studies where we had immediate post-test and delayed post-test, and in the one study that I alluded to earlier where we had post-test at 4 weeks and 11 weeks, we found that understanding grew during the post-test period, even though we could show that the growth was predicted by the expression of differences during group work. So something was happening post-group to lead to change. So certainly the Vygotskian model didn't apply with that age group in our research. However, in the work that we've done with older students, there was a hint that these things might change with age. With undergraduates, we haven't done that many studies with undergraduates, but we've certainly done more than one. The achievements during group work did seem to be relevant to pre to post-test growth. They didn't progress during the group. They didn't learn as much as those who did progress. And our work with 12 to 15-year-olds suggested they might be a sort of transition group
between reliance on what happens within the group and what we found with the younger children. So that always intrigued me when I first spotted it about 7, 8 years ago, because it suggested there might be some developmental progression in terms of the underlying learning mechanisms, which suggests a fairly complicated relationship between cognition and dialogue. However, this work was not at all conclusive, because for one thing, and in a sense I've said it already when I was talking about the younger children, progress can be made during group work without necessarily being co-constructed. I mean, you can have a discussion and something clicks during the group work, but it doesn't necessarily have to be a collaborative product. And the work with undergraduates doesn't actually, the previous work with undergraduates doesn't allow us to take account of that. A second problem with all the previous work was that undergraduates were typically closer to the target knowledge than the younger children. Is that any surprise? No, of course it's not. And a third confound in the happy story is that, of course, undergraduate dialogue differs in all sorts of other ways from the dialogues that young children have. And one particular difference that struck me, and is quite relevant to what I'm going to go on to in a moment, is that the undergraduates often brought in theoretical constructs when discussing, whereas the younger children would usually talk in terms of the situational parameters. And just to give you an example what I mean here, the younger children would talk, in the context of flotation, would talk about things floating because they're light, sinking because they're heavy. They're looking at the objects and the properties of the objects, and that's dictating their discussion. The undergraduates, even if they had no understanding of the basic theory, would still talk about things like, that object will exert more pressure on the surface, using these sort of pseudo-scientific terms, suggesting some sort of underlying theoretical model that may have been right or may have been wrong, but it was still a theory rather than talking about the properties of the situation. So lots of differences between undergraduate dialogue and the dialogue held by younger children, which made it impossible on the basis of past research to really explore this, I think, quite interesting issue. Because what we need really to look at whether there are changes with age in the mechanism of learning, to establish whether the nature of productive dialogue changes with age, you firstly need a task that's similarly challenging for all these age groups. And secondly, you need a much more comprehensive analysis of dialogue than simply looking at exchange of difference, co-construction, the variables I've been flagging up so far. And identifying such a task is not straightforward. However, and this is why when all this occurred to me about 7 or 8 years ago, I couldn't take it forward. However, fairly recently, I began to suspect that one of the classic topics in research in everyday physics might provide the solution. And in particular, simple scenarios where a ball is dropped from a carrier. Now, these scenarios vary in terms of the mass, the size, and the medium through which the fall takes place. But another way in which they vary, as you'll hear in a moment, and the way that they vary that I think is absolutely crucial for the research that I wanted to do, is that you can, of course, make the carrier move as well as hover. And I felt that this difference between fall from a moving and fall from a stationary carrier might actually be an area where I'd get pretty similar pre-test performance across a range, across the relevant age group. So why did I think that? Well, the scenarios I've just shown you were used not in a collaborative learning study, but in a recent study that I did on individual cognition with 6 to 10-year-olds. We had these scenarios computer presented, moving or stationary carrier, fall through air alone or fall air and water, and of course the variation in balls and mass and size. And what we asked the students to do in this study was to predict the path that the ball would follow as it falls by clicking on 3 series of 3 dots. Go back to the picture. They showed the students see a simulation. The simulation freezes at the point of fall. And then 3 dots appear, the middle one vertically below the balloon but quite close to it, 1 to the left and 1 to the right. Have to click on to indicate the path. Once they've done that, another set of dots appear and so on, and a third set. That's the task. The results of this study, remember this is individual, not collaborative learning, show reasonable performance with the stationary scenarios. Mean accuracy 61% correct, and there was improvement with age. However, the results also show abysmal performance with the moving ones. Do you know how objects fall from a moving carrier? I could expose myself by getting, or some people in the audience will know, it traces a forward parabola in the direction of movement. Mean accuracy with the moving scenarios is only 3% correct in this age group, and there was no age difference. They were not good at it. So I started talking about this study to my master's classes at Cambridge University, and usually to introduce them, I would give out a paper and pencil version of this task and get them to draw the paths that they would predict, and found roughly 3% accuracy in the class of master students too. And of course I was aware of the published research of McCloskey and various other theorists suggesting that very intelligent undergraduates would not know about the forward parabola. So I thought, well, maybe this is a task that I would be able to get a sample that was equivalent at pre-test and pretty bad. In addition, I had a group task that used the scenarios. Well, I had a task that used the scenarios and that I knew was suitable for collaborative group work. A slightly more recent paper. It starts with, in effect, the task that I've just described. computer presented scenarios which freeze as girl drops the ball and students are to predict the path. Then it goes on. If the students get it correct, and the scenarios include fall from a stationary carrier, which often they were correct, and fall from a moving carrier where they, surprise, surprise, were not very often correct. But if they got the answer correct, they were told they were correct and invited to observe a simulation of predicted motion, the correct predicted motion. Now, the 2012 study, as well as the prediction task that I've told you about, had a recognition task where they show the simulations of the motion. And given the results of that task, we expected them to recognize correct motion. So when if they answered correctly, they see the simulation, we're expecting them to recognize that it's correct. If the prediction was incorrect, they're invited to observe the predicted pattern, i.e. the incorrect motion that they had expected, and asked if it's correct or not. And we, of course, again based on the 2012 study, expected that the non-naturalness of these strange non-forward parabola paths would be recognised by all and sundry. If they realise they're incorrect, and the expectation they would realise very often, they're shown the correct motion and they're invited to compare it with their incorrect prediction, and they can replay correct, incorrect as often as they want. So that's the basic task, and I'm labouring it a little bit because it's the task we used in the new study of collaborative learning. So starting towards the end of last year, I ventured forth to do a study that used the age range that seemed interesting from the work that I described earlier on. The study, I mean, it was planned by me, but all the data were collected by Antonia Zacariou. I can't see her in the audience, but I think she's here, and I just want to acknowledge her contribution at this point and to say that I'm sure, she doesn't know the results. The results are quite new, but Antonia was responsible for the pre-test, the computer-presented group task, and the post-test. Time-honoured design of all my studies. The pre-test, Antonia took the students usually in the whole class at a time, slightly different with the undergraduates, showed a series of object-fall problems. I'll give you a few examples in a moment, in a whole class setting, using PowerPoint, and the students would just simply draw the path in their answer booklets. So I'll come back to this slide. I'll just show you a few examples of the pre-test problems. Didn't simply use the hot air balloon scenario. We used a train on a high bridge. Draw the path the box will travel through as it falls. Mark X where the box will land in the field. What could be simpler than that? Some of the problems, we also got them to indicate the factors which the students thought were responsible. Okay, so that's the pre-test. The pre-test also included some sort of control items, looking at general reasoning skills. I'm not going to talk about them, but I want to mention them at this point because they have no relevance to the results that I'm going to outline. So they did the pre-test. Then they did the computer-presented group task, which I've just described to you. They did it in pairs, so we had 46 pairs. Always same age, one of the 5 age groups, usually same sex. It wasn't quite. The dialogue was audio taped, it was transcribed, and then it was coded. Now the transcriber and the coder had no idea that I was interested in age differences, and the coder didn't know the ages of the children, of the students she was coding. So they were blind to hypotheses. And then a post-test, again, in the time-honoured fashion of my research. This one had exactly the same problems as the pre-test, and about 1 month after the group task. So we had a number of measures, and the only 2 that I'm going to talk about today are the predicted paths. I'm still analysing the results. I don't have the complete picture from this study. We did look at the number of relevant factors they ticked and the number of irrelevant factors, but I haven't done all the analysis. All I've done with that is to check that what appears from that analysis doesn't compromise what I'm going to say about the path from the stationary carrier and the path from the moving carrier. So, what do you need to know? So there were, we separated the scoring of the 2 paths. The possible score range for the path from the stationary carrier was 0 to 4, and the score range for the moving carrier was 0 to 8. So, this is what we found in our 5 age groups. Now, let's look at the stationary carrier. Sadly, given what I was hoping for, there were significant age differences at pre-test here, but they're kind of U-shaped function. They're maybe not quite what you'd expect. Maximum possible scores 4. So despite the differences, the point is that they're all pretty good at predicting the vertical path that the ball will follow from the stationary carrier. There are no significant differences at significant age differences at post-test. Despite the fact the year 12s were now perfect, every single one of them got it right, and so were the undergraduates. So that's the picture there. More interesting and rather dramatic is the path from the moving carrier, where actually there are no significant differences between the 5 age groups at pre-test. In fact, they don't even approach significance. So, in perhaps what's the crucial area, we did manage to find a task that was similarly challenging. But by golly, they're quite different at post-test. And there's a strong curvilinear relation with age. The 2 youngest groups improved significantly. The 2 eldest groups are almost perfect, and then the maximum score here was 8. But poor old year 10 have actually gone backwards. So that's what we find. The age difference at post-test was significant, not at pre-test, and of course, no surprises at age by test interaction. So that's what we found. So, does dialogue have anything to do with it? Coming back to, in a sense, the theme of the talk. Well, as time's tight, I can't go into details about the dialogue analysis. We started out with 11 variables that we applied to each of the 8 the dialogue around each of the 8 problems, and then by an iterative process of correlation, factor analysis, and so on, we ended up with 6 patterns. Now, 3 of the patterns I'm not going to talk about because they were rare, they were unrelated to age, and they were unrelated to learning. But the other 3 patterns I think are quite interesting, and these are the ones I want to flag up now. The first one I've called reasoned doubt. They're predicting, okay, it's the heavy one, right, yeah, the balloon moves. It goes that way, so I'd say, well, it goes that way, but, she's doubting, but it's heavy. It's a heavy one. Yeah, it goes straight, and then in the end it would drift, So she's predicting, down and out, that sort of path. Yeah, probably, there's doubt in this in this dialogue. So they're doubting the path, they're doubting each other's proposal, and they are giving justifications for their views. Now this cluster of variables, doubt, justification, and so on, it accounted for about 15% of the total dialogue, and it showed a U-shaped relation with age. I mean, the age differences aren't statistically significant, but there's certainly signs of a U-shape. And it predicted both post-test path from a stationary carrier and post-test path from a moving carrier. There was no interaction between age. The negative values, by the way, in these slides are indicative of a positive relation. It's because I centered, in order to look at the interaction, I centered the values. So if there's a negative beta value, it means actually a positive association between dialogue and learning. So reason, doubt, predicting pre to post test change, big deal surely. It just confirms the importance of differing opinions. I mean, if I found that 30 times before, this is the 31st, and I'd be shocked if it hadn't emerged. I mean, yet more confirmation that that dialogue variable is important for learning. Okay, the second one, what I've called theoretical analysis. This comes from a pair of undergraduates, and they're very theoretical. Vanessa, probably because the velocity gradually decreases. You can read it yourself, like in the horizon. I'm thinking about physics. I'm not thinking about it now. I'm thinking I don't know much because it wasn't going that fast. It doesn't have that much momentum. She might not be thinking too much about physics, but she's still using a scientific term. Linda, what do you think? Actually, I am thinking about physics. Like if there's a horizontal component and a vertical component, and the resolved one is actually that plus that, it actually should be a straight slope. You can see her logic. You think so? But in that case, I don't know why. They don't know why it's curved. If there's no air friction, we tell them there's no wind, then the horizontal component should be the same all the time. Should we just say we've thought about it? So, theoretical analysis. It didn't happen very often, only 4% of the total dialogue. It too showed a U-shaped relation with age. Poor old year 10. Just don't do it. It's, again, not quite statistically significant, but it's nudging statistically significant. The age by theoretical analysis interaction isn't statistically significant, but this form of dialogue, again, is very strongly related to post-test path M score. So it's predictive of learning on on the challenging area of the data. It's not related to path from the stationary carrier. So that's the second area of dialogue. The third one that I want to mention is co-construction. What I was, of course, the original motivation for doing the study. We had lots of this. The kids, the students are working together collaboratively to co-construct the pathway. There's no disagreement. There's no difference of opinion. They do refer to the situational factors. They do it in two ways. They do it to kind of cement their understanding of the situation. The light one. Is it the light one? Is it the light ball that we're looking at? That's what they're talking about. They're certainly talking about situational factors. They then collaboratively construct the pathway, giving reasons, but more reasons to confirm their joint understanding. They're not reasons to negotiate difference. There's a subtle difference here. And this cluster was very, very common. 72% of the total dialogue could be, accounted for in terms of a co-constructed pathway. The frequency, it was frequent at all ages, but the frequency did decrease significantly with age. 2 youngest groups used it much more than the 3 oldest groups. But it wasn't related to anything. And coming back to my, sort of hope that the Vygotskian ideas might be sort of salvaged with the older group, there was no age by CP interaction. So it wasn't the case that that co-construction became more important with age. So this section of the talk, I think, can actually end with a pretty simple message. Dialogue during collaborative group work triggers knowledge translation if differences of opinion result in reasoned discussion. The more students engage in this form of discussion, the more they learn, and that's true at all age levels. Now, older students may certainly have a richer array of ideas to contribute. They brought in more theory than the younger students. So the reasoned discussion may be richer in that sense. So they may learn more. But I think the learning process actually remains the same. And certainly as far as my data are concerned, collaborative co-construction has no direct relevance at any age level, even when, as you've just seen, it actually dominates the discussion. Now this is, I've said summary and speculation, because here comes the speculation. Even though I'm pretty adamant that collaborative co-construction isn't part of the learning mechanism, it may provide the context in which learning can take place, and perhaps it's got indirect relevance. Perhaps when you see, when you engage in dialogues like that, you feel safe. You feel, you have a sense of cohesion with your group members, and perhaps it creates the context where it feels safe to differ. So it may, maybe have indirect relevance of that kind. And I also noticed that with the older students, you saw how collaborative co-construction decreased with age. The older students seemed not to use it when it had already clicked. And I think maybe that kind of dialogue is indicative of learning going on, or the need to learn. but it's not the learning mechanism. That's the crucial distinction. So, to move very quickly to the final part, which, given I've got 5 minutes left, is also a brief section. I want to talk about, if we can take for granted that, this is the form of dialogue that's important, what are the mechanisms of knowledge transformation that are relevant here? How is it that differences of opinion create new knowledge? What goes on here? Well, to make the story concrete, I'll take another example from the study that I've just been describing. I call them a successful group because these are two children from year 6, the youngest group in my study. Both of them, both Iona and Susie, scored 0 on Path M at pretest. One of them, let me have a look which one. Yes, Susie went up to a score of 4 out of 8 at post-test, and Iona went up to a score of 8 out of 8 at post-test. So they really did learn. And this extract has, in a sense, got it all in terms of the 3 forms of dialogue I've been highlighting. There's co-construction, okay, it's moving, it's a heavy ball, it's one of them, etc. They're working together to create the path. There's disagreement, reason, doubt, and there's also some theory. It doesn't look such a sophisticated theory as you saw with the undergraduates, but there's certainly a theory that air exerts a pushing force, and that's relevant. It wouldn't go straight because it's heavy, so say a little push and then it will go. So this group, use all the variables that I've been talking about. And what I think it illustrates, and this to me is one of the crucial things about this form of dialogue, is that it's forcing the children in a natural and spontaneous way to make their sort of general beliefs explicit. If it's a physics task, so their general law, sort of physical principles. I believe that air pushes, and that's relevant to path. I believe that the ball's heavy and heaviness is relevant to path. This dialogue is forcing the children in a very natural fashion to become metacognitively aware of their general beliefs. And I think, that doesn't happen that often in other discursive, everyday contexts. I think this is important. I'm not the only one who thinks it's important, because here's 2 quotes from giants, in my view. Do you know who these quotes are from? Do you recognise them? In both cases, only under the pressure of argument and opposition will he seek to justify himself in the eyes of others and thus acquire the habit of watching himself think. Now that's the crucial thing, becoming metacognitively aware, never without the shock of contact with the thought of others and the effort of reflection, with thought as such become conscious. And the second one, the importance of struggling with another's discourse, its influence in the history of an individual coming to ideological consciousness. Reflecting, do you know who they are?
The first is Piaget.
Sorry?
The first is Piaget.
The first one's Piaget. From Judgment and Reasoning, and the second one is from Bakhtin. Okay? I'm saying it exactly. This to me is one of the crucial things that's going on. So I put forward proposition 1, Dialogue around differences of opinion naturally triggers metacognitive awareness of general beliefs. May not be the only way, but it's a natural way of bringing this to fruition, and I think that's important. But I don't think it's the only thing that's going on in my studies, and we'll carry on with Iona and Susie, where we left off a moment ago. Should we go? They want, should we look at the simulation? Still has a little, etc. Further discussion of the path, and at that, just before they start watching the simulation, they input a path that goes diagonally backwards. In other words, the wrong direction and the wrong shape. They review the simulation. Okay, let's see what really happens. Okay, see what really happens. Review the simulation, displaying the correct path. How did it? What? Why would it go that way? I've no idea. It's literally the exact opposite. Now, I could give you hundreds of other examples of this kind of thing. The point is that the feedback is quite momentous to them. It's a shock. And I think it's a shock precisely because, for once they are metacognitively aware of their underlying beliefs. They're coordinating theory and evidence in a way that much research shows is very difficult in an individual context. And I think it's these two things together that are critical. Here's proposition 2. Metacognitive awareness of general beliefs triggered through dialogue magnifies the significance of relevant events that occur subsequently. And just a couple of slides more, just to underline the point about magnifying the significance of relevant events that occur subsequently. And I'd like to briefly mention another study of mine published in 2005. This one had 8 to 12-year-olds working on floating and sinking. And the crucial thing is the 4 conditions. Condition A had it all. What they had was a pre- and post-test, which all the conditions had. They had a collaborative group task. And then at weeks, the collaborative group task came in weeks 2 of the study. The demonstrations came in weeks 4, 6, and 8. And then they did the post-test. Now, 2 of the conditions, condition A and B, had the demonstrations, but condition B didn't have the collaborative group task. Condition A responded much more productively to the demonstrations. They noticed what was going on. These were just demonstrations, there was no dialogic contextualization. Response to the demonstrations was much more predictive of their change in condition A. It was significant for them. And unsurprisingly, condition A made most progress. Evidence that dialogue was absolutely critical in triggering this process. The size demonstration, which had the demonstration that all other things being equal, bigger objects are more likely to float than smaller objects, came at 4 weeks, and it seemed to be a particularly significant demonstration. Now, within condition A, 67% of the groups discussed size, and they always had differences of opinion. The other 33% didn't discuss size at all. Now, there's, of course, a missing condition here, but, this is what happened naturally. But what's quite interesting, I think, is after the demonstration, this is just the productive condition A, the children in the groups that discussed size made 10 times the progress of the children in condition A who didn't It's got size. So, to summarise and draw some conclusions. And this is really, what I believe on the basis of the research into collaborative group work. Differences of opinion in collaborative dialogue stimulate metacognitive awareness of general beliefs. And it's that metacognitive awareness that makes the children receptive to what happens afterwards. And from the study I've just summarised, the receptivity continues for some considerable period of time. It just doesn't die down. So, of course, that's the opportunity for the expert voice and for teaching. So long, of course, as the teaching is coordinated with the kind of framework that the dialogue has set up. I think that's the important thing. And if you get these two things, then you will get individual process and progress. I could, I think, have drawn an arrow back to differing opinions in collaborative dialogue as well, and it's actually why I've drawn the thing more or less in a circle. Because if learning is only partial, and I think, these differences that I observed in the dialogue between the undergraduates and the younger children are indicative of that. If learning is only partial, then of course the learning that's taken place so far will inform the subsequent dialogue. I think, it's a simple model, but I think it's what's going on. The questions that are raised by it I've looked at science, social science, maths and general reasoning. I haven't actually looked at learning in the context of the humanities, and be interested to see whether it applies. I mean, the subsequent events of relevance in that context are more likely to be textually based, but I don't see any reason why the processes shouldn't apply. And the second key question is this model, if we want to build this into a general socio-cultural theory, is this model specific to collaborative learning, or does it have implications for other forms of social interaction? I'm not sure, but this is my story in relation to collaborative learning, and I'll stop there. Thank you.
So we have time for questions, and we have a microphone or for people who want to. Oh, there's but you have to speak loud, yeah? Please.
There's a microphone upstairs.
There's a microphone upstairs too, yeah?
A volunteer will be.
Yeah, okay.
I might not hear the questions that well, so you have to speak very quickly. Right.
Thank you for interesting talk. I guess I came to the conclusion that your data basically supports Vygotsky. If you think about the between people function, I guess it's some kind of reasoning. And for, and I was looking at the data, the co-constructed groups, to me like cumulative talk or consensus talk, agreement talk, not reasoning talk. And even the examples of successful Iona and Susie, I think, that seemed to me to be about people trying to reason together around particular empirical evidence and how to make sense of that. So I guess I came to the sort of other conclusion that one of the difficulties, I think, is the category system, what we call co-constructed. I think your colleague at Cambridge, Neil Mercer, would probably call cumulative talk rather than reason talk. So the whole notion of you have a function like reasoning that occurs between people and then it's internalised. It seems to me that your data suggests that was so.
So you want to
Okay.
answer, please?
I think it, of course, what I'm saying supports Vygotsky in the broader sense. I mean, you know, dialogue's crucial to the learning process. But where I would definitely depart from Vygotsky in translation, I mean, I have no idea what he said in Russian, of course, is over the idea that that the knowledge object is constructed between the collaborating individuals. And I think in some ways that's not entirely surprising. It surprised me when I first started obtaining counter evidence, for sure. But with hindsight, it's not particularly surprising for several reasons. Firstly, Vygotsky really didn't write extensively about collaborative learning. I mean, you know, he mentions in one of the other chapters in the crucial book about interaction with a more knowledgeable peer, but it's certainly not his focus. And I don't think he really made a particularly detailed study of collaborative dialogue. But secondly, I think the other reason why I think the position that my data point very clearly towards is a positive one, is that Vygotsky can be interpreted as a little deterministic, whereas the model that I've been putting forward allows for, it allows, of course, for a cultural input, but it also allows for a creative process, a much more sort of creative reception to that knowledge. And, you know, that's what I think cognition is, actually.
Okay. Demetrio?
Yeah.
Please.
I would go the opposite direction than the previous comment. Actually, in my view, it may not even be the dialogue that is the causal factor, but just the availability of alternative representations to the same phenomenon. So if you make them available, even without any other person being present, then you will get the same results.
Yeah. I think the data that I got from the study that I talked about in detail actually is pretty compelling about dialogue being important. If you remember two things about the study. Firstly, all the pairs got physical feedback on their predictions. They, in fact, saw 4 times that the ball fell vertically from a stationary carrier and 4 times that it fell through a forward parabola from the moving carrier. However, there were huge differences in the amount that they learned from the scenario. And poor old year 10, who hardly learned anything, I mean, they saw exactly the same, sort of right answers presented as everybody else, were the group that didn't talk and didn't have these exchanges of views or engage in the theoretical analysis. So I think, I'm not saying there aren't other things going on, but I think the results of that study are pretty compelling for a key role of dialogue.
Okay, please.
I wanted to ask whether you have the chance to look into the same issues at a younger age, around 6 to 8, because from some of the research we've done here in Cyprus, comparing 6 to 8-year-olds with 10, 11-year-olds, actually we're finding much more support of the idea that dialogue can actually promote cognitive development compared to older children. So I wanted your opinion on that. And second, I would like to ask whether the idea of socio-cognitive conflict from the first generation of research in Geneva of Doaz and Munich, how that is related to your work, and whether, since you discussed the idea of socio-cultural theory, you see identity and social identity like gender identity or other forms of identity being or need to be part of such a theory. Thank you.
Gosh. Talk number 2 coming up now. I'll answer you briefly. I haven't done much work with children below the age of 8. I mean, I've done individual cognition work with younger children, and I've also looked at younger children in informal play settings, but I haven't used these collaborative group tasks with children below the age of 8. In terms of how it all relates to work on cognitive conflict, socio-cognitive conflict and so on, I mean, for sure, what I'm expressing in terms of differences of opinion, in a very simple term, relates to the ideas of socio-cognitive conflict, transactive dialogue, exploratory talk, and so on. You know, there's many interrelated ideas in the literature. In terms of cognitive conflict as opposed to socio-cognitive conflict, in some ways my answer is I'm not sure. What I said at the end of my talk is probably what I'd want to reiterate, which is that collaborative dialogue involving differences of opinion is a context where the sorts of processes that I explained, I think are crucial for learning, are elicited naturally and spontaneously. It would be very interesting, and of course it, an important issue for theoretical analysis and future research, to think in terms of, is it the only context where these things could happen? I doubt it. But if it's a sort of uniquely natural context and nothing more than that, then I think it becomes quite important, because you begin to ask questions like, have we evolved into the kind of species, is that the function of collaboration in our, evolutionary history and so on. So these are big questions, and I'm not going to attempt to address them all. I haven't particularly looked at identity in the sense in which, this is the final bit of your question, I think, in the sense in which you're flagging it. I've looked at gender differences and, sort of markers of identity, ethnicity and so on, but seldom actually find them that important in the context of this kind of research. I do think, we come back to year 10, when I've worked with 15-year-olds in this recent study and other work, they find it excruciatingly painful to engage in dialogue with the opposite sex doing these tasks. I think it's just not cool at that age group to do this kind of thing, and to explain why year 10 didn't talk and ergo didn't learn. I think identity is couldn't be more important.
Okay, please.
Just 2 short questions. The notion of culture would mean that you have to take into account the fact that dialogue has different values in different cultures. Could this be a Northern European kind of reasoning that we see, and when we move to Southern Europe, it might be different? And the second short question, what happens at the age of 10, please?
Okay. Yes.
Please.
Sorry. I need to move across to hear the question and then move back to answer it. I'm aware of, the literature on collectivism and individualistic cultures and so on and so forth. I'm aware of research indicating that there are cultural differences in the use of group work generally in classrooms, and therefore the ease with which students would adjust to tasks like mine. I don't think that necessarily means that if you succeeded in creating a context where these tasks would take place in non-Western cultures, the processes of learning, or indeed the learning outcomes, would be different. I mean, I think that's an issue to be explored, but I certainly completely agree that it's probably easier to set these tasks up in a Western context, even in as many as these studies were, the earlier studies took place, even in very deprived areas of the city of Glasgow, which is the most deprived city in the UK. These things are important and interesting.
Okay. Are there more questions? Please.
If different opinions and awareness of belief has and the knowledge experience has an effect on learning, I guess it also has an effect on the collaborative understanding that's coming out of the dialogue. What is the role of this collaborative or collective understanding in your model and on the learning of the individual?
I think this comes back to the speculation that I advanced at the end of the second the major section of the talk, that although the things that they were doing jointly in terms of constructing knowledge objects, namely the paths, was not instrumental in learning, and my successful group illustrates that dramatically, really. They consistently put in the wrong path, and yet there was this massive progress. So it's not central to the actual mechanism by which learning takes place. But I think I'll go back, to my speculation and perhaps refer to, say, Peter Koenig's work, emphasizing trust and the development of trust during a collaborative exercise. I think that it's perhaps this sort of sense of working together, of creating something jointly, is creating the context in which you feel, it's okay to differ. You're not threatened by the difference. I mean, difference can have many different meanings. It can be seen as a personal attack, or a constructive contribution to the discussion. And I think the bits where they were working jointly and collaborating and constructing things jointly are probably important to creating that sense of trust.
Okay, I think we are at the end, and thank you very much for this interesting discussion.